Hello everyone, and welcome to this session around bringing RAG at scale in the enterprise. We are going to spend the next half hour together, so I'll start by introducing myself and then deep diving into the topic. I'm Caroline, and today I'm a senior product manager working on the topics of AI and machine learning at Dataiku. Before that, I used to be a customer-facing data scientist, and I've always been passionate about how to leverage AI to solve real-world business challenges. Today, we are going to focus more particularly on a new technology, RAG, Retrieval Augmented Generation, why it can be useful, and how you can leverage Dataiku to tackle the challenges that RAG is bringing to the table. So let's start with an introduction on why this talk. In the past months, within Dataiku, we have supported dozens of customers in setting up their first generative AI use cases, and we have learned a lot on the way. The first learning is that RAG is definitely one of the most promising generative AI use cases. It's often the first use case that our customers want to implement when we talk about Gen AI. And usually, setting up a POC, a proof of concept, is relatively easy. It can be done in a few weeks. Many frameworks exist. It's very well documented, and there can be a wow effect the first time that you build a RAG proof of concept. However, obtaining real business value with a safe and scalable use case is more challenging. So the transition from design to production can be complex. This is why the talk, and now what you should take away after this 30 minutes together. First of all, if you are not familiar with the RAG concepts, do not worry, because I will start with an introduction on the basics of the RAG methodology and some common business applications. Then the core of the presentation will be dedicated to showing you the main traps that you should avoid when you're deploying large-scale RAG products. And along the way, I'll take the opportunity to explain how Dataiku can help you reach your goals when it comes to RAG. Let's get started with RAG basics. This part will cover what RAG is and why we need it. Okay, so you might probably have experienced playing with some large language models. The results are impressive. However, using LLMs in a business context is often not enough. Why? First of all, because these large language models lack specific, up-to-date and non-public knowledge. If you ask a large language model a question that can only be explained by your private documents, it will obviously be wrong. If you ask a question on a very recent fact, you won't get an accurate answer, etc. The second problem is the uncontrolled possibility for hallucinations. So what do we call an hallucination? It's a scenario where a large language model generates an incorrect answer that looks very credible, very real, and there is no way to fact-check the LLM answer, which can be obviously problematic in a business context. Finally, if you want to ask a question on a very dense document that you have, an internal document that is describing typically your safety guidelines, you want to feed this document to the model and ask it a question on the document that you just fed, you might come across the limited context windows, meaning that we cannot input an immensely large prompt to an LLM. There is a limit to the number of sentences that we can feed to a large language model, meaning that on some cases, this might be a blocker. So for all these problems that can happen with large language models, Retrieval Augmented Generation can help you. How? First of all, the concept of RAG is to enrich the LLM knowledge, so what the LLM has learned during its training, with your own data. Then the LLM will not only answer with a plain response, but will justify its answers with some precise paragraphs that have been extracted from the documents that you have enriched the LLM with, which can be very helpful if you want to fact-check the answers that have been generated. Finally, RAG is also a way to be cost-efficient and computationally efficient via context selection. I don't need to feed a huge document to my LLM to obtain an answer. because retrieval allows me to select only the relevant pieces of information before feeding them to the model. So I believe that a concrete business example is worth 1,000 words. So let's take two examples that we have implemented with our customers at Dataiku. First, LG Chemical. Here we find a very common pattern for RAG use cases. An internal support team within your company creates a bottleneck because it receives too many employees' inquiries. So here, the idea was to package a very important number of documents around health and safety documentation in a RAG web application that became a first level of support for LG Chemical employees. Obviously, the advantage of this method is that you save time for the employees that are supposed to answer the support tickets, and you have them focus on very complex questions that cannot be addressed with a simple web application based on RAG. Another example that we implemented for an international fashion company is to enable very easily any employee that wants to build a web app, a chatbot based on some documentation, it could be corporate policies, procurement, store operations, to package this knowledge within an application so that Dataiku and the application that was created in Dataiku with what we call Dataiku Answers becomes a single entry point, easy to control for any employees that wants to learn on a specific topic of interest on a specific internal documentation. So here, the real advantage is the faster time to delivery. As you will see in the rest of the presentation, packaging such an application can be done very fast in Dataiku, and is also the ability to centralize all the initiatives in a central place. So now, how does it work? We've seen that RAG can have real business value, but what is hiding behind this value? I will go step by step with an example to explain the very basic components of RAG. To do that, let's imagine we want to build a Dataiku assistant that can help with most typical user questions, such as, in this example, what is a Dataiku project library? The first main component of RAG is documentation, knowledge. We need to gather all the useful information that could help answer users' questions. So in the Dataiku example, the idea would be to gather the Dataiku documentation, Dataiku tutorials, Dataiku courses in a knowledge repository. The second component is what we call the retrieval component. So when a user asks a question, the role of this component is to identify the most relevant paragraphs of the knowledge corpus that could help answer the question. What is key at this stage is the way the initial corpus is splitted into paragraphs that we call chunks, and the retrieval method that we use. So how do we find the most relevant paragraphs based on a query? There are several retrieval methods that exist. The most common one is to compute a similarity score between the user question and all the paragraphs that we have available in our knowledge repository. So here, for instance, we could imagine that the retrieval component is going to fetch every single element in the documentation that mentions project libraries. The last component is the generation. This component provides a final answer based on the user question, the retrieved elements of context, and relies on a large language model. Typically here, we could have an answer around project libraries. It's a place to store code that you plan to reuse in your project. What's nice is that we can display along the answer of the large language model the sources that were used to generate this answer. So now that you know how RAG works and that you've seen a few business applications, we can transition to the second part, As I mentioned in the beginning of this talk, setting up a basic RAG system is relatively easy. However, improving it, evaluating it, and deploying it can be more challenging. In this section, I will go over some traps that we've observed at our customers, and it will be also the opportunity to show you how at Dataiku we address and solve these challenges. The overall flow of building and deploying a RAG model is quite similar to a standard machine learning lifecycle. We start by exploring our data, exploring our documents. Then we prepare these documents, we split them, we create some chunks, potentially we clean our documents. Then we build a first RAG model. We can try out different retrieval methods, for example. We evaluate the different approaches that we took in order to choose our favorite one. And then comes the deployment phase. So after validating that the RAG pipeline is compliant with our internal criteria, we can deploy the RAG pipeline, typically as an end-user application. And lastly, the two final circles are around what do we do once the application is deployed. Obviously, we want to monitor it, to obtain user feedback, and to continuously improve it. So this is really nothing new. However, when working with generative AI and with RAG, each of these steps has some particularities that can make it quite difficult to implement it in real life and more challenging than expected. So listed below, you can see 4 key traps that we have identified and that I will go over in the next slides. Underestimating data preparation, relying solely on advanced data scientists, minimizing the importance of evaluating your model, and lastly, poorly managing risk and usage controls. Let's get started. The first trap is underestimating data preparation. As in any machine learning model, the quality of your final pipeline highly depends on the quality of your data. So you need to make sure that the useful information, the information that can help generate better answers, is fully and precisely extracted from the documents. The problem is that here, our data quality is actually document quality. And these documents can come in many different formats: PDF, documents, slides. They can be contain complex layouts. They can contain potentially images or tables that are complex. Extracting all this information properly is not straightforward, but if you manage to do it properly, it will increase dramatically the accuracy of your final pipeline. At Dataiku, we enable you to apply various advanced extraction techniques, enabling you to transform complex documents into structured information that can be consumed by a RAG application. So here we are talking about optical character recognition techniques, advanced text extraction libraries, or even custom approaches that will vary depending on the documents that you feed into your pipelines. On top of these document extraction recipes, we have invested for a very long time since the beginning of Dataiku in data preparation. You might know that one of our oldest features at Dataiku is the prepare recipe that today has close to 100 processors, and that we enrich every day with new processors, and in particular with GenAI specific processors that can help you chunk and process your data so that it's as clean as possible and helps you improve the quality of your final RAG models. The second trap is to rely solely on advanced data scientists. So what we have learned on the way by implementing use cases with our customers is that neglecting subject matter experts and end users always leads to misaligned solutions. And here, the challenge is really embarking users with different skill sets and expertise on a single generative AI project. Let's say, first, these GenAI pipelines are not regular ML models. When you build a classical machine learning model, a data scientist optimizes a model based on predefined and agreed metrics, and then the model is exposed via API or for batch scoring. And that's the end of the game. The thing is that RAG pipelines bring an additional layer of complexity. First, we are not talking about a single model. It's more a chain. You have various steps, data preparation, prompting, that can happen for a single result to be displayed. Then these RAG pipelines encapsulate knowledge. So what you want to embed in a RAG pipeline is a specific knowledge that is represented by the knowledge corpus. And in general, this knowledge is detained by subject matter experts. Developing a model without taking into account the people who master the documentation and the knowledge is bound to fail. For instance, how can you evaluate a RAG model on internal safety documentation if no one in the project knows the safety guidelines and the safety documentation? And finally, most generative AI use cases and most RAG use cases involved users, end users, that consume an application via a front end. These users need to be involved because they will be the final users and to be involved. So this is the first thing. And then obviously, as we're talking about front end, about web application, you can also imagine that we need non-data science skills, such as software development skills. Many different profiles that need to collaborate on these use cases with a very varied skill sets. How Dataiku can help? First of all, at Dataiku, we have always invested on collaboration. And this is the same for our RAG features. A non-coder in Dataiku can implement a full RAG pipeline only with visual elements. A coder can do the same and can go even one step further, doing everything in code, if there is a need to customize or to go one step further. So this is the first thing, enabling different profiles to collaborate on projects, whether they can code or not. The second thing is that we have always invested on web application. It's been possible for a very long time to build web applications and user interfaces in Dataiku. But in the last year, we have invested massively in helping users deploying state-of-the-art chatbots with only a few clicks. This is materialized by Dataiku Answers, which is a web application that can be deployed in a few clicks, and that is today used by hundreds of users at the time I'm speaking. Trap 3, minimizing the importance of evaluation. There are new models every week. As you can know, like try to follow the evolution of the LLM world, you have to be fast and be very active. Benchmarks are one thing. So we have general and public benchmarks, but what you want to know is what are the approaches that work best on your specific data and based on your specific constraints. So here, the challenge is to be able to easily evaluate your GenAI and RAG pipelines. However, classical metrics cannot be applied easily to generative AI use cases. There is a need to invent new metrics. So, why? You can ask yourself, why do we need to use new metrics? Well, first of all, when a large language model answers, there is no right answer. Several variations of the answer could be satisfactory. So it's very difficult to say right or wrong and to compute an accuracy metric. Additionally, we do not only care about the validity of the answer. For example, we might also want to know if the model has based its answer on the provided context or if it's hallucinating. For all these reasons, at Dataiku, we have embarked new metrics, LLM-specific metrics, that can be used for Q&A use cases, and that are very helpful to assess the performance of various pipelines in terms of answer validity, but also context relevancy, and many others. It's great to be able to evaluate your models one shot when you want to select the best model to deploy, but it is also critical to monitor the performance of these models even after their deployment. For instance, discrepancies between The metrics that you monitor after deployment and metrics that you had computed at design time could evaluate that the model is not used in the way you thought it would be used. The questions are not the ones you were expecting, and it could push you to iterate on the model. So that is why at Dataiku, we are working a lot on how to monitor metrics and user feedback over time for continuous improvement. Typically, in Dataiku Answers, it's extremely easy, a few clicks, to set up a feedback mechanism where you can suggest the end users to vote and rate the answers they get. Last trap, poorly managing risk and usage control. So what we have learned is that these Gen AI technologies are bound to be widely used in the enterprise. The targeted end users is basically anyone. And the challenge comes obviously with the number of users, because we need to make sure that each person has access to what he or she needs and not more. But the challenge also comes with the diversity of users. Among these users, not all of them have the same knowledge and the same skills when it comes to AI. Here, there is a clear need to put some guardrails to control both costs, but also usage when deploying RAG use cases. First, very important thing, in Dataiku, we are working for it to be very easy to monitor and manage costs in order to find the perfect balance between quality and price. So this comes with monitoring control dashboards that are very customizable, but also the ability to set up rules to monitor your budgets. The second thing is our work around guardrails. Guardrails are here to help you define some strict policies on how the models can be used. For instance, detect toxic questions or toxic answers. Make sure that you are not a victim of prompt injection. So prompt injection is a method to trick a model with the goal of having it answering something it's not supposed to answer. We have some specific models to detect and filter out these prompt injection attacks. You also have the possibility to implement your custom policy hooks depending on your internal policies and the way you want each model to be used. So now, as a conclusion, what should you take away from this presentation, the various traps I've presented? The first thing is that if you have not already, you should definitely explore the potential of RAG for your business. Be curious, generative AI is here to stay, and RAG is one of the critical use cases that we've seen at our customers. Second thing, navigating the journey from RAG POC to enterprise RAG and scalable RAG is complex. As we've discussed, preparation, evaluation, deployment, you have challenges all along the way that make the operationalization of your RAG projects challenging. And obviously, Dataiku is here to help. We have now an extensive experience around setting up RAG use cases and deploying them, and are continuously working on delivering a seamless, collaborative, and innovative experience from start to finish on our RAG use cases. I hope this presentation was insightful, and I'm very happy to answer any other questions. Thank you very much for listening.